This is the ME-157 Can Crusher Design Project. Our group members include Ka Pham, Chris Breacher, Ryan Chow, and Dylan Tate-Mull. The overview of the project includes the product description and motivation, project requirements, concept generation, decision matrix, final selection, design layout, force analysis, spring design and calculations, and finally manufacturing and technology risk. The group's project will be to design an aluminum can crusher that will allow the user to significantly reduce the size of a can in order to more effectively store recycling. Currently, many homes and businesses throw away their aluminum cans instead of fully taking advantage of the income that is lost due to not recycling. On average, each can that is not recycled is a loss of 5 cents, and for these large locations such as restaurants, bars, and airports, this can quickly add up. By creating a product that will quickly and efficiently crush cans, consumers will be able to take advantage of this income that is usually just thrown into the garbage. Originally, the group intended to design and create an automated can crusher that would allow the user or consumer to compress aluminum cans rapidly without a manual input force to crush the can. This design was initially favored because an entirely automated system was believed to be the best option to crush aluminum cans. However, the decision was made by the group without taking into the voice of the customer thoroughly, so we took a step back and went to talk to 2 different customer groups, both in the commercial and residential applications. From this, we were able to form a list of 10 requirements for the project, and these are as follows. Crush 6 cans in under 20 seconds. Can must be reduced in size by at least 1/3 of its original. Must be easy to operate for both young and elderly users. Has the ability to store up to 6 cans at a time. Ability to mount to a wall or cart for portability. Lightweight for easy transportation and setup. Must utilize gravity to remove and feed cans into and out of the crusher. Must be made of recycled materials, must be easily serviceable, and the system must be long-lasting and reliable.
Concept generations. 7 different concepts were proposed. 1. Use a foot and a 4-bar link to compress the can. 2. Use a ram compressor to compress the can. 3. Use a leveler compressor. 4. A leveler feeder compressor. 5. A manual crank. 6. A foot pump compressor. And 7. An automated crank can compressor. After generating concepts, a decision matrix was used to give a quantitative evaluation of the wide variety of selections at hand. By the PUG matrix method, it was determined that a manual lever feeder can compressor is the best choice, better than the anticipated automated crank that we initially thought.
The final selection for the project is a manual lever-fed can crusher. Originally, the group strongly believed that automating the can crushing process would be the best selection. However, manual operation had the highest rating by each group member, and therefore a manual operation will be pursued. Shown to the right is an initial concept idea that the group came up with. This is the final design layout. The machine has a 6-can capacity, can be wall or cart mounted depending on the consumer application, and is constructed of lightweight aluminum that is easily machinable. The can crusher is gravity fed, and with each can that is crushed is dropped below into a small bin or waste container. Here is a side view of the machine with both extreme positions overlaid on top of one another. This slide shows a can loaded in the machine as well as a can falling below after being crushed.
Force analysis is performed to calculate the force needed for users to crush an aluminum can using this design. An aluminum can with 340 milliliters averagely takes 120 pound force to crush. By drawing out free body diagrams and using the sum of moment equations, this led to a result of 28.9 pound force required for users to crush a can with the machine. Force is reduced to a quarter of the original 120 pound. The purpose of the spring in this design is to pull the handle back to the initial position. The specification required the spring to pull a force of 29.5 pound force at an extension of 6.1 inches. That gives the spring rate K equals to 58 pound force per feet. We started with the cheapest material of aluminum A227, choosing the wire diameter of 0.1 inch and curvature factor of 8, resulting in a safety factor of 1.97, which is greater than 1.2. This shows that our spring design is suitable.
If the group wanted to produce a prototype and bring the product to market, we assessed the manufacturing and technology needed. Standard machining practices were specified throughout the entire report, so no issues would be found in manufacturing. Technology is also readily available for production as well. If mass production were considered, automating the machining process would be necessary in order to reduce labor costs and the time required to produce each can crusher.